I told you about the chromatic, monochromatic aberrations. Now I will tell you the spherical aberration. As you know that name is given the spherical, it means that there must be something spherical in the lens. So what is that spherical? That is the surfaces of the lens are spherical. Because of that we are having this spherical aberration. The lens have spherical surfaces. So there is spherical aberration. When we say the spherical, it means that it has something. It has the diameter, radius, aperture. So what is that? The aperture is that is the diameter of the lens. So now if we know that this is our lens, this is not so much. This is the diameter. This is also called the aperture. So aperture of lens is equal to diameter. So that is equal to D. So this is what that we are having this D. Since there is aperture in the lens, so we are having this spherical aberration. The spherical aberration is due to aperture of lens. Larger the aperture, larger the spherical aberration. Larger the aperture, more is spherical aberration. It means that the aperture is the measurement of the spherical aberration. So spherical aberration equal to the aperture of lens. Aperture of lens. And this is equal to the diameter D. This is what that I have told you this here, D. So if we measure the diameter, we can measure this spherical aberration. Now I draw the diagram. Let's suppose we are having this lens. This This is now object O. This is the point object. The rays start from this one. These are the marginal rays. This is the paraxial ray because they are near to this principal axis, and the rays which are at the marginal points of this lens, where there is the marginal part of this lens, they are called the marginal rays. So marginal rays that they after to this so this is, and that this rays after focusing they will spread like this one. So this is now these rays now then these two rays, this is suppose paraxial, so this is now your IP, and this is now image, this is now your marginal, so this is now IM. So these are the marginal rays. These are marginal rays. And these rays, this ray which is near to this principal axis, this is the paraxial rays. Paraxial rays. So this image point object is corresponding to this paraxial, and this is for the marginal image. So between these two we are having the images. You see that here the paraxial and the marginal rays cross each other. So because of that we are having this here a image. So this is a this will be like this one. So it will have the cross section of this one, that will be the circular. So this is the circle. This is called the circle of least confusion. So this is called what to name it? Circle of least confusion. And this is now suppose its radius, this so much. This is the radius of this circle. Marginal rays and paraxial rays. Of point object. Point object O. As we just you write down position of P, then this will be no more better. The marginal and paraxial rays of the point object P converge at points IM and IP after refraction from lens so they make IM and IP are images of point object P. So it means there are two images, and you see that this IP is at a more distance from this lens and IM is nearest to this lens. So between these two images there will be number of images. There are number of images between IP and IM. Now you can see that if the screen if a screen perpendicular to the principal axis is moved between IM and IP, a luminous circle is visible. The image of point object will be luminous circular disc. Circular disc. So it is what? The disc, that is the diameter. So the difference between IM and IB, this is the longitudinal spherical aberration, and that the diameter or this the radius of this circle of least confusion, that is called luminous circular disc. So now what we have? circular disc is minimum where between IM and IP, where the marginal and paraxial rays cross each other. Cross one another. Then this is called the circle of least confusion. It is called circle of least confusion. Now, why the word is confusion taken here? Because we are having the number of images, number of circular discs. So now the question is that what should be the exact one? So for that, when we are having the this circle of the minimum radius, that we will call the circle of least confusion. So here this confusion is very small, and in the remaining part the circular discs are of higher radius. So because of that there is the more confusion. So here when the paraxial and the marginal rays cross each other, then there is the circle which is of minimum radius. So this circle is called the circle of least confusion. Longitudinal spherical aberration. This is equal to IP minus IF. So what the difference is between the distance of this marginal rays and the paraxial rays, that they converge at the points on the principal axis. So that difference is called the longitudinal spherical aberration. And there is the longitudinal transverse spherical aberration also, because the ring that is formed is just perpendicular to the principal axis. So this is now suppose principal axis like this, and this is now circular disc. This is circular disc. Then we are having this principal axis. So this radius is perpendicular to this principal axis. So because of that, that is called the transverse spherical aberration. Transverse spherical aberration is equal to radius of circle of least confusion. Least confusion. So this is equal to the R. This is the radius. R means the radius of this circle of least confusion. So that will give you the transverse spherical aberration. So if you find the difference between the distances of the images along the axis, then this will give you the longitudinal spherical aberration. If you find the radius of this circle of least confusion, then that will give you the transverse spherical aberration. So this is about the spherical aberration, and I think this is not given in your the 12th class book. So you read it very carefully, and also what the topics I am taking, they are very important from the point of view of the examination. So you are all advised to read very carefully and note the things which are important to you. And also, if you have any kind of confusion or any kind of question related with this by the videos made by me, then you can ask me or you can write in the comment box. So if you like it then you share and subscribe the video. Share it as much as possible so other students could also find the benefit of this one. So this is all about the spherical aberration. So thank you. Bye.